Hi, my name is Welder, and today we are going to solve this problem. Let's take a look on it. From the top of the Eiffel Tower, a jogger, so here you see the jogger, is spotted heading toward the tower. At 2 p.m., the angle of depression of the jogger in point A, so right here, was measured to be 37 degrees. So here it is, 37 degrees. 4 minutes later, so here on point B, when measured again, the angle of depression had increased by 35 degrees by this amount. Find the average speed of the jogger to the nearest foot per minute. So that is the question. So we need to find the average speed. So what is average speed? So let's do the solution for this problem. In first place, how can we find a expression here in order to answer this question, the average speed? Well, by definition, the average speed of a object is the displacement divided by the time elapsed. Well, the time elapsed in this problem between point A and point B, as the exercise tells us, is, let's take a look here again, 4 minutes. So 4 minutes later, so here the time elapsed is 4 minutes. So now we just need to find what is the value of the displacement. Of course, we are going to do that in feet because the height of the Eiffel Tower here is provided in feet. Okay, well, first of all, take a look that this is a right triangle. So here in yellow, I'm highlighting here, you see a right triangle. Let's draw this right triangle here on top, and let's take the information that we have from it. So here is the right angle. We have that the height here of the tower is 986 feet, and we desire to discover what is the distance from point A to point B, because that is the displacement that we are looking for here in order to find the average speed of the spotter here, of the jogger. Well, so we need this. Well, how can we find this? We can first find the measure of this site and then subtract from point B to point C. If you do the subtraction from this segment from the segment, so you have exactly the segment that you desire. But what is the measure of this? Well, in order to solve that, we can find here what is this angle after all. See, as this here needs to be a 90-degree angle, if you subtract this 37 from that 90 degrees, you get exactly the angle of the vertex D, this angle. Let's do this subtraction. So this angle right here is 90 minus 37. So that is 53. So that angle is 53. Let's put it here, 53. Now we have a angle. With that angle, we can use sine. We can use here sine. So let me just change here my color for this one. So the sine of, I think another one here will be better. So just a moment. So the sine of that 50. So let me put there again the 50, 53. So sine of 53 is just equal to opposite side, which is this entire side, AC, divided by the hypotenuse. In fact, we can do better. We can use tangent instead of sine. So here, instead of sine, let's use tangent. And then now we have the tangent of the AC, which is the opposite side, divided by the adjacent side, which in this case, so adjacent side here, which in this case is 986. Well, this value we can get from a calculator, so let's go for this value. So tangent of 50 degrees is this number, so approximately 1.327, approximately 1.327, and then by multiplying by this 986 both sides, we find that AC, so that here implies that AC is approximately, so let's take this on calculator. So let's do this. So this value here multiplying by 986. That is approximately here. Let me just write this number. 1308.5 approximately. 130608.5. So 0.5. Let me just reduce this here in order to gain more space here. So 0.5 here. This is the measure of the side. But what we desire is this. So now we can take a look on this smaller triangle, right triangle here, and then use tangent again, but now tangent of not 53, but just this angle right here, which is the 53 that we had there minus 35. If you do this subtraction, so 53 minus 35, 53 minus 35, we get 18. So the tangent of 18, that is BC divided by the same number here again, 986. That tangent is approximately, let's take the value here of it. So tangent of this angle, which is approximately 0.325. 0.325, and that implies that BC, which is the value that we are desiring to compute here, is approximately, let's do this computation. Let's open the calculator here again. Let's multiply this number now by 986. So 320.37. So approximately 320.37. Let me just use two decimals for the first one as well. The first one was, let me just go over it here. It was this one, which is 47 approximately. So 47. Instead of this 5, let me place here a 47. So 47 approximately. Okay, this is enough for our purpose. And now we can find the value of AB just by subtracting AC from BC. So let's do this. So let me just reduce this here. Oh, let me try to do this properly. Okay, this one. Let me place this here. Let me erase this here. Okay, and now let's do the subtraction. So let's use the calculator here for doing this subtraction. So this value here is the one that we need to subtract from 3 to 0.37. Let me just use the same number that I'm using there in my approximation. So by doing this, the value that, let me just see here. What is going on here? Oh, okay. Okay, it's the other way around. We need to subtract this value, which is the BC, from the AC value. So here it is. So 988.1. So then AB is approximately 988.1. Let me just see it again. Okay. Well, and now that we have this value here, the value of this side, we can now find our average speed, which was our goal from the very beginning. So let me take the yellow car here again. So that average speed can be computed as the displacement, which is the value of AB, which was the displacement of the jogger, which is here 988.1 divided by the time elapsed, which is 4 minutes. The result needs to be delivered in foot per minute. As this here is in feet and this here is in minute, so simply by doing this division, our result will be in foot per minute. So let's do this. So let me just reduce this here, and then this here is approximately, let's take our calculator, this value divided by 4, which is 247 approximately. 247 foot per minute, which is the answer. So here, foot per minute, which is the answer for this problem to the nearest foot per minute. I hope you have enjoyed, and see you in the next video or solving another problem. See you there. Bye.